of all the types of factoring, we're good at one part of the trinomials, but we struggle with the other one. And I'm going to show you one way involving grouping that we covered yesterday, and then I'm going to show you another way that I have found that kids seem to like, and there's kind of a trick to it. And so hopefully you'll like it, and that'll kind of clear that type of setup up for you. We're talking about two different kinds of things. We have a trinomial with a leading 1, which those are the easy trinomials. Those are the ones you do great at. It's the second one, the trinomials where they don't have a leading 1, where we tend to run into a little more difficulty. And some of that stuff I hope to clear up today. And for those of you who have had some difficulty with in the past, I think you'll like this, okay? Anyway, we'll start off with the easy ones, okay? And that's the trinomial with a leading 1, just so we're clear about what we're talking about. We're saying that when you have a trinomial in descending order, okay, so it's got 3 terms. In descending order, the first coefficient is 1. Descending order meaning, of course, that the powers go down from left to right. Just as a general rule, this is what the setup would look like. Once you put your trinomial in descending order, you'd have a 1 in front of the x squared. Then you'd have some bx. This could be minus. This could also be minus if c is negative. Okay, but this is the type of situation we're talking about. Trinomial in descending order, the coefficient is 1. And we'll talk about some of the strategies to solve this, and you'll remember them when we go through them. And so here are actually, you don't have to write these down, but just these are examples of what they would look like. Just in case we were unclear about what they look like, these are what they look like, all right? You got an x squared or a y squared or a z squared or a c squared, and then you work your way down. They could be positives, they could be negatives, but this is the type of environment that you're looking for in order to use the strategy I'm about to show you, okay? Now, I'm going to go through it like maybe you haven't done this before. If you know what to do, you can go ahead and factor it yourself and go through it. But I'm going to go through it with the steps, explain the steps, and you can apply that, generally speaking, to any of these kinds of problems should you get to them. So the first example that we're going to look at is a really simple one, x squared plus 8x plus 15. If you think you know how to factor that, go ahead and do that. All right, overall looks pretty good. So let's just run through what the steps would be. Okay. What you're doing, just in general, so what I have here in black is for any type of trinomial with a leading 1 if you're trying to factor. You're going to find the factors of the last term that add up to the middle term. Okay, keep in mind, watch the signs. If this was negative, we'd be finding factors of negative 15. And so what are the factors of 15 that add up to 8?
3 and 5.
3 and 5. So that's what we're looking for this problem, 3 and 5. That's all there is to it. Most of you had that. So you had x plus 5 and x plus 3. That's fine too. Okay, doesn't matter. Okay, are there questions about that? Like I said, walking around looking at what you guys did, most of you had that. Let's look at another example that's a little trickier, but still not that difficult. This is still a leading 1. Got my descending order, n squared, n, constant, coefficients 1. I threw a negative in there to make it a little more challenging, so go ahead and write that one down and try to factor that one. So one of the things that I find us struggling with sometimes is finding the right factors, okay? Because we're looking for factors here of negative 48 that add up to 13. And let's say you're in that position where you're just not sure. You're not sure what they should be. Here's the advice I have for you. Off to the side, just start listing all the different factors of negative 48. And you can start with the most obvious ones. You know, maybe go 48 and negative 1. What does that add up to? Well, that's 47, right? So then we go to 24 and negative 2, that's 22. So that's not going to work either. We're going to pretend you don't know the right answers for a minute. Because oftentimes with 48, one of the things you guys jump to is this. Right? 8, 6. That doesn't work either. So I know my first term is going to have to be between 8 and 24. And I'm playing dumb for a minute on purpose, because I want to sort of show you when you can't find the factors, some strategies. If you're stumped now, let's say you were stumped, okay? Well, there might be one. You might go with what? You might also try, this one is sort of not unusual, right? You might come up with that one. That doesn't work either. So oftentimes with a number like 48, the one that you miss is not one of these. Okay, I don't know why the correct ones don't pop out at you, but for whatever reason they don't. Let's say you go through this list and you're stumped and you can't come up with anything else, and you think, okay, I guess it's just not factorable. Before you do that, before you make that conclusion, what I would ask you to do is try to look inside these numbers. And when I say look inside, look for factors inside of those numbers that you haven't already used. Now, again, we know what it is. But for example, if you still couldn't come up with it, maybe you look at this 12 and go, what other things go into 12 that maybe we haven't used yet? We used 6, we used 2, we used 4. But what haven't we used? We haven't used 3. So if you get stumped, you can look inside the factors and go, oh wait, there's a 3 in here, there's a 3 in here, there's a 3 in here, there's a 3 in here. I haven't used 3 yet. Well, maybe you don't know 16 times 3 is 48 off the top of your head, and you got to get your calculator and punch it in and whatever. But that's the strategy. So obviously the right answer is 16 and negative 3. But for whatever reason, that's just less of a, that's a trickier set of factors for whatever reason, right? I think what it boils down to is we know this one, we know this one. Half is always going to be an even number, so we come up with that one. But we don't necessarily know our 3s all that well, okay? So that's one strategy that I recommend. If you get stumped, try to look inside the numbers for a factor that maybe you hadn't thought of yet. And then a lot of times that'll be you're sort of missing. And of course, this is n plus 16, n minus 3. You can go the other way too. That was the easy style. This is the one you guys are usually pretty good at, historically speaking. Where we run into trouble is this kind of problem, when it doesn't have a leading one. Okay, I'm going to show you. I've showed you when you were in my class a couple years ago. If you're in my class a couple years ago, okay, I showed you. There were videos that you had to watch. I showed you something called the box method. Okay. If you want to use the box method and that's what works for you when you do this, that's great. Okay, if you want to guess and check, do that. That's great. I'm going to show you grouping today, since we just covered grouping yesterday. I think it lends itself to it. Then I'm going to show you a way that I've not shown you before. Now, you may know this way. Another teacher may have showed you this way. I know that I've had some success with it recently, so I thought I would show it to you because I think, generally speaking, this is the kind of factoring that really kind of trips you up. So hopefully you'll pick one of the ways I show you today, and that'll build some confidence for you. All right, here's the form we're talking about. Now, instead of this leading coefficient being a 1, it can be anything. It's still going to be in descending order, x squared, x constant. But now this number in front will be any number other than 1. Now, the steps I'm going to show you to start with are going to be the same for the grouping method, and they're going to be the same for the other methods that I'm going to show you. So this part is consistent. The biggest change, and maybe you know this as the ABC method too. I don't know. I've heard that one too. The biggest change is that instead of just looking at the last term, we actually have to make sure it's in here. We actually have to multiply A times C. Okay, so this step here is critical to figuring this kind of factoring out. In reality, I guess you could really do that idea when it has a leading 1 too, because then it's just 1 times that, which is the same thing. So if you want to just remember one way, you could always remember this way. And so that, once we do that multiplication of A times C, then you're finding factors of A times C that combine to give you B, or BX. So that's the difference. In the leading 1, we found factors of C that add up to B, or combine to B. Now we find factors of AC that combine to give me B. That's the biggest difference. And that's the key to unlocking these problems, is again finding those right factors. Once you find those right factors, then these problems get a lot easier. Otherwise, you're just guessing and checking. When I was taught this, when I was in high school, they didn't teach us any tricks at all. They're just like, okay, you just got to figure it out and hope you get the right ones. Find things that multiply to give you C, find things that multiply to give you A, and then foil it out and see if it works. That's how we had to do it. That's how I was taught how to do it. And some of you may have been taught that way too. Back in my day, we had just pencil and paper, and I can literally remember being 15 years old, erasing so many different numbers so many different times because I couldn't come up with the right combination of numbers that it erased a hole in my paper. I can still remember this, 35 plus years later. You guess and check until you find out, okay? And I'll be honest with you. So I didn't learn any sort of strategy or trick other than guess and check until I was a teacher. And now I got a whole bunch of them. And so to me, this is the key. If you can do this and figure this out, the rest is pretty easy, okay? So, and then of course, in our case, what we're going to do is rewrite BX. So we're going to change, this is if we're going to use grouping. So I'm going to take this term and I'm going to split it up. I'm going to turn it into 2 factors. I'm going to rewrite BX using the factors that I found here. And so I'm going to take my trinomial and make it a polynomial with 4 terms. And then I'm going to factor by grouping. Okay? That's the first way I'm going to show you. But again, the key is finding the correct factors that I need to use. And once you do that, the rest of it should become pretty easy because factoring by grouping is pretty easy. All right. And then again, I'll show you the other way after. We're going to do the same problem, just 2 different ways. And you decide which one you want to use. If you want to use either of those. If you want to use guess or check because you're good at that, use that. If you want to use the box method from what I taught you a couple years ago because you like that, use that. I don't care. I just want you to get it right. Okay? So here's the problem we're looking at. 6x squared plus 23x plus 7. So we're in descending order. X squared, x, nothing. Okay. My leading coefficient is not a 1. So there's going to be a little extra work involved. Okay. So once we've checked for descending order, now my first move, and this will be the first move in both methods I show you, is to multiply those 2 numbers together, the A and the C. That gives me positive 42. Be careful of your signs. In this problem, it's positive, so that's going to be positive 42. If this was a negative, or if this was a negative, it's possible that this could end up being negative. So once you do that multiplication, it reverts back to the same strategy as when it had a leading 1. I need to find the factors of 42 that add up to 23. What is it? 21 and 2. Okay, so those are my 2. Once you find those 2 factors, the rest is really kind of simple work. But the hardest part of the problem is coming up with these, because this is the key. This is the key to unlock the problem.
Where do we put these?
I'm going to show you.
Oh, but you leave A and C the same?
Yes, A and C stay the same. So now what we do is once we find these, what we're going to do is we're going to change this middle term. Okay? We're going to rewrite that middle term. Because we're going to use 21 and 2 to take my trinomial and turn it into something with 4 terms. Okay? And then we're going to group it. So what it looks like is, okay? And you have to have the x's on there, otherwise it's not going to work. Okay? So 21x plus 2x. You could put 2x plus 21x. It doesn't matter. Either way. And now just group it and finish it and you're done. Okay, so go ahead and finish it. All right, so you're going to group. So I'm going to put those two together. My common factor here is what? 3x. Okay, what about over here?
It's just 1.
Okay, I do need the 1. So even though there's technically, your first thought when you look at this, there's nothing in common. There's always a 1. With grouping, you need the 1. Because you have to have that second part of the binomial. So my common group is 2x plus 7. And then I've got my 3x plus 1. And that's what you would do for solving by grouping. Okay? If you like grouping, if this seems like a good idea because you've struggled in the past with trinomials that don't have a leading 1, then I encourage you to use this. Okay? The next method I'm going to show you is... You maybe have heard this one before. Maybe you've heard it. It's called slide, divide, bottoms up. Yep. Anybody heard that one before? I got a whole bunch of kids this year that have heard of that one, and they really like it. And so I'm going to show it to you. Okay? And it's kind of a trick, but it doesn't require you to do grouping. Okay? All the first part is the same. So this part, that part is called the slide. I know you can't see it. Okay, that's the slide there. When you slide 6 to 7, and then you multiply, and you find the factors. That part is exactly the same. None of that is different than what we did before. Okay, here's where it gets very different. The divide part is you're going to take each of these factors and you're going to divide it by this leading coefficient. Okay, and then it's just going to be x. So here's what I'm talking about. Here's the divide part. So instead of putting 6x squared, they're both always x or y or z or whatever. And you're taking these two factors and you're dividing by 6.
That was way harder.
Yeah, I think I'll stay away.
Well, I'm going to keep showing it to you because the rest is pretty easy. Of course, the next thing you have to do is reduce. Okay, so you have to reduce those fractions. So 21 over 6, what is that? 7 over 2. This is 7 over 2. What's this?
1/3.
1/3. So that's really important. You got to reduce. Okay, so we did the slide. We did the divide. Reduce is not in there, but you just have to do that. And then here's where the bottoms up comes in. So this comes up and goes in front of the 2. This comes up and goes in front of the 3. So there's your bottoms up. Okay?
You like this one?
Now, again,
Bottoms up.
so the key, the first part is the same, right? You do the slide, which is the multiplying. You come up with the factors. That's exactly the same. From here, it gets very different. And then it goes back up. Here's one thing that you need to know. Sometimes these fractions will reduce to an integer, which means there's nothing to make go up. All right, so if this would have ended up being 4, let's say this whole thing was 4, then x plus 4 would be one of your factors, and you would have only had to move the 3 up. Okay, do you want me to go through that again?
But it still works if it's...
No, just leave that up, though.
I can leave it. Yeah, it'll still work. Yeah, for sure. It still works. Okay. So again, the slide is the multiplication and find the factors. The divide is you divide each of those factors by a, reduce, and then the bottoms up is where we end up getting our final answer. Obviously, the problem is the same. The answer is the same. We got the same thing both ways. Whatever way you're more comfortable with is fine with me. This one's more of a trick, okay, than the other one.
Did
But
you discover this?
Bro.
no, I did not discover this. I did not. If I did, I would have called it something different besides slide, divide, bottoms up.
Yeah.
I mean, that kind of flows. It's got a good little flow,
That's
but
what
I wouldn't have come up with
discovered
that
it 'cause it
No.
blew off.
one. No, there's
I
some
think you'd call it like the Zook method.
Zook method. You think?
Yeah.
Okay.
Probably.